Hi everyone, in this video we'll be starting with the database fundamentals, wherein we'll try to answer 4 main questions. First is where the data is stored by the database. Second is how the data is stored. Third is why the data retrieval process is slow in the database and how we can improve that. Okay, so now let's try to understand this animation. So here we can clearly see that the round trip from CPU to memory takes around 100 nanoseconds, whereas the round trip from CPU to SSD takes around 50,000 nanoseconds. So this means that if you store the data into the memory and if you're trying to retrieve that data, then it would be 500 times faster compared to when you store the data into SSD, right? So now you might think that the memory is very fast for data retrieval, then database might be storing that data into memory. But storing the data into memory has two major drawbacks. The first one is memory is very expensive, right? So if you go to buy a 64 GB of RAM, and on the other end, if you go to buy 1 TB of hard disk, then obviously you have to pay more for buying that 64 GB of RAM. So firstly, you are paying more, and secondly, you are getting less, 64 GB versus 1 TB, right? So that's the first drawback. And the second drawback is memory is volatile storage. So whatever data you are storing into the memory will be lost when you shut down your computer. So because of these two major drawbacks, what database does is they avoid storing the data into memory. Instead, they store the data into disk for durability. Okay, for durability. So you can either store the data into SSD, which is solid state drives, and or you can store that into hard disk drives. Okay, so I hope now you got the answer for where exactly your data is stored. Now let's try to understand how the data is stored onto this disk. Okay, so for that, let's try to understand this table first. So assume that you have this users table wherein you have 4 columns: ID, name, status, and age. Okay, and let's say there are total of 1000 users into this table, right? Now in order to calculate the total size of this table, what we generally do is we first calculate the size of each field, right? So let's say ID is an integer, right? So the size of ID would be 4 bytes. Okay, similarly age is also integer, so it will also take 4 bytes. And let's assume that the name and status will take 38 and 150 bytes in total. Okay, so one entire row over here will take 200 bytes, which is the addition of all these numbers, right? So in order to know the total size of this table, what we do is we just multiply this 200 with 1000, because there are 1000 users. So 200 into 1000 is nothing but 200 kilobytes. Okay, which is nothing but 0.2 MB, right? So this entire table takes 0.2 MB of size. Now let's go back to this diagram. So here this table is stored onto this pages. So you can clearly see this A1, A2, A3, B5, C7, etc. right? So those are nothing but pages. By the way, some people call them as blocks, but we'll refer them as pages. Okay, so these are the pages where your data is stored. But the thing is, each page will have a maximum size of, let's say, 4 kilobytes. Okay, you cannot store 0.2 MB of data into one page itself, right? So you need to break that down. So what we generally do is we break this table down into multiple parts so that we can store that into these pages, right? So how do we break this down? So in order to do that, there's a simple math. That is, if one row is going to take 200 bytes, then how many rows will take 4000 bytes? So if you do this math, then you'll get the 20 rows. Okay, so 20 rows. So what we'll do is we'll take 20 rows and put that into page number 1. It can be any page. Let's say we store that into A1. Okay, then we'll again take another 20 rows. We'll put that into another page. Let's say A2. Then again we'll take another 20 rows and put that into A3, and so on and so forth. Okay, so this is how we store the data into the pages or onto the disk. So one point to note over here is one page will have multiple rows. For example, here we were having 20 rows in one page. Okay. So I hope now you have an idea like how exactly your data is stored onto the disk, right? Now let's try to understand what is a full table scan. So for that, let's first see what is this query saying. This says that we are trying to select all the columns from users table where the name of the user is Bob. Okay. And one more thing that you need to keep in mind is each page has total of 20 rows as per our example which we discussed. Okay. Now what we generally do is we take one page at a time. So first I'll take this page, go through the 20 rows which are present in this page, and let's assume that there was no data related to Bob in this page. So again, I'll keep this page into the disk. Then again, I'll take out another page, go through 20 rows, and let's say I was lucky enough to find a row where the name is equals to Bob. So what I'll do is I'll keep that row aside into, let's say, RAM. Okay, I'll keep that row into the RAM and again put this onto the disk. Now, instead of stopping, we continue the process. That is, I'll again take this particular page, go through 20 rows and do the same process again and again, right? So that's why this process is called full table scan. We are scanning the entire table, isn't it? We are going through all the pages where your table is stored in chunks, isn't it? So this is what full table scan is. And by the way, this is a very slow process. Why? Because we already saw that the round trip from CPU to SSD takes around 50 microseconds. This is just for one page. So if you are trying to retrieve 100 pages, then it would be 50 into 100, which is 5000 microseconds, which is 5 milliseconds. So just for finding a specific row, it is taking 5 milliseconds, right? This is quite bad. So we cannot use a full table scan. So what should we do in order to improve this data retrieval process? So is there any way to improve this data retrieval efficiency? Yes. So the answer is we can make use of a black box. Okay. What this black box will do is it will help you to directly retrieve that page where your data is stored. So now instead of going through each and every pages out there, you will directly get that page where your data is stored. How awesome, right? So this black box is nothing but index. So this index will help you to improve your data retrieval efficiency. And there are many types of indexes which we'll look into the next video. But I hope you understood full table scan, which is very slow for data retrieval, and why we need indexes. Okay. So I hope now you understood all these questions. If you did, then please like the video so that this video can reach to more and more people. Thanks for watching.